Okay, we're going to do Unit 7, Lesson 9 on comparing shift patterns and just understanding the way that place value shifts as we multiply by 1/10, 1/100th, 1,000th. It's real similar to when we multiply by 10, 100, or 1,000. So we'll solve some multiplication problems with those decimal numbers. Okay, it's 2 pages if you need SAB, 287 to 288. This should go fairly fast. Okay, so we're going to complete the sentences and just go through this exercise on this page. You guys just need to fill in the blanks as we go. When you multiply by 10, the number increases, right, by, it gets 10 times bigger. The place shifts one place to the left. Sorry. Right, when we multiply by a 10th, it gets a 10th as big, and the place shifts one place to the right. Okay. When you multiply by 100, the number gets 100 times as big, and the places shift 2 places to the left. Whereas when you multiply by 100th, the number gets 100th as big, so a fraction as big, and the place shifts 2 places to the right. Moving on, when you multiply by 1,000, the number gets 1,000 times bigger. It shifts 3 places to the left. And when you multiply by 1,000th, it gets 1,000th as big and shifts 3 places to the right. Okay, so I want you guys to do your big idea right here. This is kind of like your big idea. How is multiplying by 10, 100, or 1,000 like multiplying by 1,000, 10th, 100th, or 1,000th? Think of this as your big idea and fill that in so you can come and share that with your group tomorrow. Okay, so if you need to pause the video to do that, do so. Okay, we're going to go on and look at what happens when we multiply 3 and 1/6, or sorry, 3 3/6 times 10. I ignore that decimal to start with. I would look at this like 36 times 10. So I know it's 360. And then I would go back because there's 1 digit behind the decimal. I need, in the factors, I need to have 1 digit behind the decimal in the product. Again, 1 times 36 is how I view this problem. So it's 36. And then because there are 2 digits, 1 up here and 1 down here, behind the decimal, I need to have 2 digits behind the decimal in the product. So if they're there in the factor, they've got to be there in the product. Again, I just multiply 100 times 36 to start with. And then I know that there's 1 digit behind the decimal in the factor, so there has to be 1 digit behind the decimal in the product. Same thing here. 1 times 36, right? And then there are 3 digits behind the decimal. You got 1 here, and you have 2 right here behind the decimal. So it's got to go over 3 spots. And I kind of look at this like 1, 2, oh no, I don't have anything here. I got to put a 0 placeholder in, and then I can put my decimal because I need to end up with 3 digits behind the decimal. It doesn't go at the end of the number because we want to make it that much smaller. Remember, zeros at the end when they're in decimals don't really mean anything. So don't make that error. I'm going to do 1,000 times 36. Again, I just like to ignore those decimals and not let them bother me and then go back. 1 digit behind the decimal in the factor, so 1 digit in the product. So there we go. Same thing, 36. Okay, and then I'm going to count them again. 3 here with that 1 and 1 here, so I need 4. Well, I only have 2. I have to add 2 more zeros and add that decimal place. Okay, 1 times anything is that same number, so you guys should know that rule and just go with that. This is the same rule, 1 times anything is that number. If you need to add that 0 at the end just to understand that placeholder, right, of digits behind decimals, go for it. Okay, so moving on, we're just going to do some solving of these problems. 2 times 5, right, is 10, 1 digit behind the place value. Just put that decimal in. Okay, it's talking up here about how these have an extra 0 in the product because of the 5s pattern. Remember, when you multiply a 5 times an even number, you just get that extra 0 in there. 5 times 4, 40, right? 3 digits behind the decimal place, so I need to have 3 in the product if they're there in the factor. 5 times 6, right, is 30. And then I need to have 4 digits in the decimal place, so just add those extra zeros on in. Okay, put that there. Okay, 4 times 5, 20. 2 digits behind the decimal place. Okay, so that extra 0 that it's talking about is this 0 here on the end, right? And it just really doesn't mean much of anything. It's considered an extra 0 because remember, when you're working with decimals, those zeros at the end don't mean anything. They could go away. You would say this number as 4 hundredths, not 40 thousandths. And so just the way that we read them. Does it work like the big idea about the product having the same number of decimals as the factors? Yes, that still holds true. That doesn't change. Okay, so these problems are all expressed the same, but either different ways. So we're just going to multiply them. 3 times 9, 3 is 9. 3 whole times 3 is 9. If you want it to look the same as the other, you just put the decimal in. Okay, 3 times 3 again is 9. This one's got 2 zeros, so it would look like that. It doesn't really change anything. Again, all of those answers still say 9. So is the big idea of the product having the same number of decimal places as the two factors still work? Yes. Do your answers all mean the same thing? Absolutely yes. Okay, so yes and yes. Okay. Ada and her family are canoeing in the wilderness. They carry a canoe along the trails between the lakes. Their maps give each trail distance in rods. They know a rod is equal to 5.5 yards, so we're going to do some multiplying. We're going to find each distance. Black Bear Trail is 8 rods, so I'm going to take 8, and I'm going to multiply that by 5.5. Okay, 5 times 8 is 40, so I'm just going to put my 0 down, carry my 4. 5 times 8 is 40, plus 4 is 44. There's 1 digit behind the decimal, so 1 behind the decimal again, so 44 yards. 44 yards. Okay, and I know I did shortcut method there. If you guys like the other methods, please use whatever method it is that you prefer. I know a lot of you are still using that lattice multiplication. That's just great. You go right ahead. Okay, I'm going to set this next one up, and then you're going to pause it and multiply. It's 9 3/10 for Flower Trail, and you're going to multiply that by 5 5/10. So pause the video and try it out. Okay, welcome back. 5 times 3 is 15. 5, carry my 1. 5 times 9, 45, plus 1, 46. 5 times 3, I need to put a placeholder because I've moved on. Okay, 5 times 3 is 15. Carry that 1. 5 times 9. 45 plus 1 is 46. Okay, and then I'm going to add. Bring my 5 down, 11, 6 and 5 is 11, carry my 1, 6 and 4 is 10, plus 1 is 11, carry my 1. Okay, now I've got to go back and get those decimals. So notice that there are 2 digits behind the decimal places in the factors, 2 digits behind the decimal places, and the product puts the decimal right there. So when I go to answer it, I'm going to have 51 1/1500 yards. Okay. All right, let's set up the next one, and then you can pause if you want to and try it out, or you can just watch me work it out, your choice. 24 1/10, we're going to multiply that by 5 5/10 as well. Okay, again, I ignore the decimals and I go back and put them in. 5 times 1 is 5. 5 times 4 is 20. Carry my 2. 5 times 2 is 10, plus 2 is 12. Moving on to the next 5, add my placeholder. 5 times 1 is 5. 5 times 4 is 20. Carry my 2. 5 times 2 is 10. Plus 2 is 12. Add. Okay, bring my 5 down. Bring my 5 down. Bring my 2 down. 1 and 2 is 3, and a 1. There are 2 digits behind the decimal, so 2 digits behind this decimal. I get 132 and 55 yards. Okay, let's go on to the last problem for the day. One of the world's largest diamonds is the Star of Africa, which is 530 and 2/10 carats. A carat weighs about 2/10 of a gram, so we're going to multiply by 2/10. What's the weight of the star in African grams? 2 times 2 is 4. 2 times 0 is 0. 2 times 3 is 6, and 2 times 5 is 10. And then 2 decimal places over, okay? So just go over 2 decimal places. So the weight of it is 106 and 4/10 grams. Okay, all right, we'll see you guys in class. Make sure that you have your big idea on that previous page filled in. So that's flipping back here and this big idea. Make sure that's taken care of for class. All right, guys.